Okay, so we're going to begin a new chapter, chapter 1. It is going to be starting our actual calculus material. Up to this point, we've just been reviewing. So this is called a preview of calculus. It's kind of going to overlap what we did last chapter in your previous classes, along with calculus and how calculus can give you a more in-depth, exact, fluid version of what you've done throughout your math classes before. All right, so what is calculus? It's just the mathematics of change. So we're looking at velocity, which is how quickly something is changing with respect to time. And acceleration is how quickly that is changing with respect to time. And if you think of slope, we've always called that as rate of change. Tangent lines are also going to be related to slope. A tangent line is a line that crosses a curve in exactly one place. Area is a relative of change. So as area is changing or increasing or decreasing, same with volume and arc length, and so on and so forth. But those are just some examples, some of the things you're going to see, but we're going to do it in terms of change instead of just area or just volume. So this chapter is really basic. You need to see the homework. It's just going to be asking you to pick what would be done with calculus, what would be done without calculus, and then actually do some of the calculations for it. You may need area or volume formulas. Those are in the very back of your book, like literally attached to the hardcover on the back. So do that. So if we start here, if you look at area in terms of calculus, you can see area without calculus, think your geometric rectangle, and then area with calculus is we don't have to have that perfect geometric shape. That shape is changing along the curve, and we can actually make those calculations, and we can make them very exact to a certain point. With work, you may have not done much with work in physics unless you've taken physics or are taking physics, but we'll do work both ways with a constant force and with variable force. A center of a rectangle is another concept in geometry, but in calculus, you can find centroid region. We will not be doing that. It would be farther into calculus, more like Calc 2, but it is a concept that is taught in calculus. So we've done lengths of straight lines, but we'll be able to find lengths of curves, things like that. Surface area of cylinder, and if you look at that, it's very even and very flat, and we have formulas for that. But this is a different formula. If you look, it's not the same throughout it. It's got a different shape. Okay, we'll be able to calculate things like that using calculus. So constant density, where density doesn't really affect. So if you just think you're finding your mass, your volume of just a regular shape, well, what if you had a cup of water? How much mass does that hold? Well, versus a cup of, I don't know, pudding. What's that going to hold? Again, you can see that things like this, they're easier to calculate. We have formulas for that. This, it doesn't have a constant top or side. It changes, it slopes down. We can calculate that. We will do those type of calculations. This next one is sum of a finite number, and you did sums. We did sequences and stuff in Algebra 2. We'll see some sums here, and we'll do some infinite sums. We'll do both of these coming up soon, actually. Without calculus, the color on this picture is kind of bad, so hopefully you guys can see well enough. But we were able to find outputs. You think of f of x and function notation. Those are just the y value when given some input. So if I plug in this number, I get this number for my y value. That's all it is. This one is more talking about what value is it approaching when I'm coming close to that x value. Okay, so that would be something that's really helpful if your graph jumps, like a step function or a piecewise function where it jumps. I can still find close to what that value is when I get infinitesimally close, and that is called a limit. So remember that word, because we'll see that a lot coming up. Slope of a line, change in y over change in x, if you remember that. We did that in a section in the last chapter. But we can do slope of a curve. This is when I talked about tangent line earlier. This is a tangent line. It crosses a curve in exactly one place. We'll use the slopes of tangent lines often, okay, for what we're going to do. And that does a lot for that. So the rate of change at that exact point. So this one here, slope of a line, is change over time. This would be instant change, okay? Secant lines go through two places. In calculus, what we'll do is we'll move these points closer and closer and closer together so that we get a tangent line. Okay. Average rate of change between two values is something you can do without calculus. Okay. Again, that's slope. All of these are talking about slopes. Instantaneous rate of change is again talking about exact that place. Okay, so we have average rate of change and we have instantaneous rate of change. And you'll see the difference of those when we do our calculus. We'll be able to do lengths around a circle or lengths along a curve. You'll be able to do height of a curve at a certain point, something before, but we'll be able to do the biggest part of a height. We'll be able to calculate how high it actually goes on a curve, not just a random height. We will not be doing this in this calculus class, but it is something that goes in with calculus. Is, in geometry, if you were to do an advanced geometry course, your tangent plane, when I say advanced, I mean more like college level, but your plane can be tangent to a sphere, kind of like a line. It's going to only touch in exactly one place. A sphere, again, has a very uniform shape, where in calculus it doesn't have to go to a uniform shape. And then this is something we will do, direction of motion along a line. It's easy to do that in, probably would have done it in junior high science class, just motion along a line, very, very basic elementary physics, where we'll be able to do motion along a curve and how fast things are moving, how quickly that is changing. So that is probably the shortest notes you will have, so don't get used to it. But that is it for notes. Your homework is just going to be applying the concepts of what's more basic, pre-calculus or before, and then what would use calculus. If it uses pre-calculus, you are expected to do the calculations. There is not a single problem on this homework that doesn't require some level of work. So even the multiple choice problems at the end, make sure you show your work. Do not turn in stuff without work. Make sure you're clicking save. Cami is supposed to be saving for you. It may help if you were to make sure you save it on your own before, so you can go ahead and grab this little thing up here with the floppy disk. Click that and make sure you're actually saving it, because people are having issues with saving. Okay. Double check it after you submit it. You can reopen it and see if your work showed. So there's no excuse for not knowing that your work's not come. You guys need to make sure you're getting better about turning your homework and turning on time. Any homework that has been due already, if I don't have it by Friday, it will remain a 0. So if you would like to get any credit back for that, you can. The later it is, the less credit it's worth. So make sure you're getting that done. And that is it. I will try to have your test graded by the end of the week. So I will talk to you guys later.